Hi everyone, this is going to be a supplemental video for week 11. So far prior to spring break we've learned a bunch of tools. We will be learning some tools as we go ahead, but I'll be making some of these videos to sort of show you applications as well as motivations behind these things. So this week we are focusing on what is called a quadratic equation. Now before we get to quadratic equations, let's look at some examples of how these things are, how these functions and ideas came to be. Now you will recall something called a linear equation, right? So there are a few ways of looking at it. Linear equation means that the power of the variable is 1. So things like y equals 2x or y equals 2x plus 1. And then visually, what it looks like is a straight line. All right, so etc. Now, what's the idea behind this? A simple example would be, let's say, thousands of years ago, a very common observation is that going from point A to B takes, say, a fixed amount of time. Why is that? Now the reason for that is the distance is given by speed times time, which means that between distance and time there is a linear relationship. Now if you walk or run, you will know that for a given distance you have a ballpark of how fast you can run, and as long as you run at that speed you take the same amount of time. So this is what is called a linear relationship, and it turns out, for example, if you were to plot it, right, distance, I'm calling it S because that's a common notation, and time, at time 0 you are at distance 0, and then as time increases your distance from let's say distance from point A, you start at A and you walk, increases linearly. Now the reason we draw this picture is we can find a bunch of other information from these graphs. So this is an example of a linear relationship. Now something that people were interested in even thousands of years ago is how do objects fall. So now we know they fall because of gravity. Now the interest among the people was to understand when something falls based on gravity, how does it behave. Okay, so there's a very smart experiment which was done by Galileo. What he did was he took a bunch of inclined surfaces and he put a ball on the top and he let it roll down to the bottom, and he recorded the time taken. And what he found is that in case of a free fall, the distance, all right, is proportional to the square of the time, okay, which is not a linear relationship. This relationship is what we now call a quadratic relationship, which means, for example, when time is, say, 1, say your distance is 1, but when time is 2, your distance is about 4. If time is 3, then your distance is 9. Now in terms of physics, what this means is that your object is accelerating. It gets faster and faster as it gets to the bottom of the ramp. Yeah. So this is sort of a motivation to understand what a quadratic relationship is. or this is the birth of a quadratic equation. So that's sort of the motivation. In the next video, I will tie it down to graphical interpretations of quadratic equation.